All right, so back for another video lesson. Chapter 5, Section 2, Perpendicular and Angle Bisectors. This section is pretty easy, um, so this shouldn't take us too long. And I won't give you guys the worksheet today, so you guys can finish your skill builder and um, anything else that you need to catch up on. So a perpendicular bisector will divide a segment into two congruent parts and will form right angles. So as you can see from the diagram, two right angles, okay, it makes AD and DB congruent, okay. It also makes CB and CA congruent. Okay, so when we see the word bisector, it means it's dividing something into two congruent parts. So if a point is on a perpendicular bisector of a segment, then it's equidistance, so equal distance from the endpoints of the segment. So they're saying if CD is perpendicular to AB, then AD equals BD and CB equals CA, okay, which is stated right there. So if you have a perpendicular bisector, the sides and the bases of the triangle parts will be congruent. Hopefully I didn't make any mistakes in the 5-1 worksheet I'm putting online. If so, just let me know. All right, so the converse of the perpendicular bisector theorem says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Okay, so if these two sides, PA and, if those two sides are congruent, and I draw a perpendicular bisector like you see in the dotted line, okay, that would make those 90-degree angles. And then I know they're perpendicular, okay? So it's also going to make AM and MB congruent to each other, okay? We're not going to actually ever have to write what theorem we're using, okay? So just telling us how to solve these. And like I said, this section is really easy. Okay, so using the perpendicular bisector, what is the length of AB? Okay, so notice that they're not asking me what x is. They're asking me for the length of AB. But in order to do that, I need to find x. Okay, so this is a perpendicular bisector because I have my right angle. Okay, so that means that those sides are also congruent to each other. So we will set them equal, okay? So, oops, wrong number. So subtract 6x, and you get negative 2x equals negative 10. Okay, well, what happens when we divide by a negative? We get two negatives equal a positive. X equals 5, so let's plug that back in. 4 times 5 and 6 times 5 minus 10. If they don't equal, then we've done something wrong. So 20 and 30 minus 10 is 20. Okay, so that's kind of basically what this section is about. Okay, so again, these two sides are going to be congruent to each other, so we'll set the x's equal. Okay, solve for x. So 6 equals 2x, so x is 3. Okay, so again, let's plug that back in. So 3 times 3 minus 1, and 5 times 3 minus 7. So 9 minus 1 is 8. 15 minus 7 is 8. Okay, so the length of QS is 8. Length of AB is 20. Sorry if this is sloppy. I didn't bring my good stylus with me to Dallas. So I'm using one that they actually gave us. It's not bad, but it's not great either. Okay, if, like I said, for some reason you're lost and you didn't get this and I go too fast, okay, you can rewind this. You can watch it over, okay, because it'll be on Canvas. Okay, so 2 more theorems. If a point is on the bisector of an angle, then the point is equidistant from the sides. Okay, so it's saying that if QS bisects PQR, okay, which is this entire angle here, whoops, okay, then we have 2 perpendicular angles and these sides would be congruent like it says. Okay, the opposite, if a point is on the interior of an angle and it's equidistant from the sides, then the point's on an angle bisector. So we can draw the angle bisector and get congruent parts and congruent angles. Okay, so basically, use the angle bisector theorem, okay? So there's a bisector, so I know that this and this are congruent. Okay, but once again, it wants the length of RM, okay? So I know that they're congruent. Let's set them equal. Okay, x is 5. What's the length of RM? So that's this. So 7 times 5. Okay, let's just check this one. So 2 times 5 is 10. Plus 25 is... Okay, so they both work out to be an even number. I mean, the same number, not an even number. Okay, so same thing here. 6x plus 3 equals 4x plus 9 minus 4x. 2x plus 3 equals 9 minus 3. 2x equals 6. So x is 3. Okay, CB would be this. Whoops. This would be CB, so 6 times 3 plus 3, 18 plus 3 is 21. So let's check it here. So 4 times 3 plus 9, 12 plus 9 is 21. So then I know I did it correctly. Okay, so if you want to check if you get x, plug it back into both of them and see if it's equal. If not, go back and check your work, because then you probably did something wrong. All right, find the value of, so we're going to use this diagram to answer all these questions. Okay, so I know that this, oh, I'm telling you, I'm having issues, which I'm sure comes to a big surprise. Okay, so I know that this is a perpendicular bisector. It's giving me the right angle. It's giving me that these are congruent. So then I know that these are congruent. Okay, so to find the value of x, I'm going to set these equal. So I have negative x equals negative 5. X equals 5. Perfect. Let me erase some of these marks here so you can see. Now find TWL. Well, that's fantastic because there's no L. let's okay. I don't even know why that there's an L there. That's just bizarre. That's weird. So we want to find the side length TW and WZ. Okay, so 2 times 5 is 10. 3 times 5 minus 5 is 10. Perfect. So what kind of triangle is TWZ? Okay. Anybody know? Okay, these are both 90. They share a side. Okay, they're isosceles. Okay, 2 sides are congruent. It's an isosceles. Okay, and I just really messed this whole slide up. So if this is supposed to be y, if y is on the perpendicular bisector of TZ, then y is, okay, so what it's asking is, what's the relationship of y to the segment TZ? So think about this. What is the relationship of YZ and TY? Okay, so this segment and this segment. Okay, well, they're congruent, so I know that it is equidistant from T and Z, or just like I said, TY equals ZY. Okay, so I'm assuming that I thought that was R and it's supposed to be a Y. Either way, you get the gist of it. I hope. You never know with me, right? All right, so how far is Mars from Jupiter? I'm just kidding. That was really dumb. According to the diagram, how far is L from HK? Here's HK, here's to L. It's 27 whatever, units, miles, feet, whatever. How far from HF? Okay, well, they're congruent, so it would be also be 27. Okay, so here's the segment HF. There's the distance to from L to HF. Okay, how is HL related to KH? Wow. To KHF. It is the perpendicular. No, it's not. I was thinking of the side. So we're talking about KHF, which is this entire angle. It's the angle bisector. Okay? The value of y, so that would mean that that and that angle are congruent. So it wants me to find the value of y, so I'm going to set those equal. Two y equals 18. Y equals 9. Find the measure of angle KHL and angle FHL. So how do I do that? Well, these are pointing to those two angles, so I have to plug in y. So 6 times 9 and 4 times 9 plus 18. Okay, 6 times 9 is 54. 36 plus 18. Okay, so each of these angles here are 54. Like I said, this section is pretty easy. Basically, you're setting these equal to each other. All right, this is the one that trips up the kids every year. I wish I knew why, but I don't. So in the diagram FD, so this line right here is the perpendicular bisector. Okay, what does that mean? First of all, it means that those two are congruent. It means those two are congruent. It also means those are congruent. So when you look at it, you're not going to set 8y plus 2 equal to 7x minus 6 because you got a y and an x. Okay, you're going to set the y's equal to each other and the x's. And this guy has a both x and a y, and we'll deal with that in a minute. And then it wants you to find all the values. So first of all, let's find y. So 8y plus 2 equals 4y plus 18. So subtract 4y minus 2. 4y equals 16. Y is 4. Boy, that's some crappy handwriting I have with this thing. All right, let's find x. 5x plus 16 equals 7x minus 6. So I'm going to add 6. 5x plus 22 equals 7x minus 5x. 22 equals 2x, so x equals 11. Okay, once you have that, you can find everything that you're looking for in this diagram here. Okay, so first it wants AB. So here's AB, okay? So 8 times 4 plus 2, because y was 4. 32 plus 2, 34. CB better be the same, okay, because they were congruent. So 4 times 4 plus 18 is 34. Okay, next they want AD. Which is here, and that's x, and that's congruent to that. So 7 times 11 minus 6, because x is 11, 77 minus 6 is 71. Okay, 5 times 11 plus 16 is, okay, if your congruent parts don't match, you did something wrong. Okay? So make sure that they match. You guys will do this obviously much neater. Like I said, the stylus is not working. Now, AE which is just this. And here, like I said, we have 2x plus 4y. What do you think we're going to do? Okay, well, we're going to plug in x and y. So 2 times 11, which is x, plus 4 times 4, which is y. 22 plus 16. So AE is 38. Now, make sure you watch because they want AC. That's the entire line. So I'm going to have to double 38, which would be 76. Okay, I know that was messy, and I apologize. Basically, in a nutshell, set your x's equal to each other and solve. Set your y's equal to each other and solve. Okay, plug x and y back in to find all your side lengths. Okay, that's all this section is on. Like I said, I'm not going to have you do a worksheet since you have, hopefully you finished your 5-1, if not, finish that. And then you have your skill builder, which is due. Okay, so I will not get the retakes done probably till Monday or Tuesday, but hopefully maybe sooner. So have a good day tomorrow and be good as always.